What's up there, Math 1? This is Mr. Bainey, and this lesson is 10.2, Fitting a Linear Model to Data. So in the last lesson, we dealt with creating scatter plots and then finding a line of fit just by observation and then being able to write the equation of that line of fit. Remember that line of fit is used to help us predict certain things. We know that it doesn't fit all the points perfectly, but it gives us sort of a pattern or a trend that we can observe and then be able to predict what's to come. And this lesson starts off with residuals and a residual plot. You'll want to be familiar with what a residual is. The residual plot we're not so much going to focus on here in this lesson, but a residual is how far away the predicted value is from the actual value. So we can get a predicted value for anywhere on the graph for any x value, but there are actual outputs that we get from the scatter plot or from the points that are already given to us. And so we'll look at what that actually means. Okay, let's go and skip all the way ahead to your turn on page 455. And we're going to be looking at, we have this scatter plot here of 4 points, not very many points. We'll usually deal with a lot more points than this because we'll get a better line of fit. But let's say we got this scatter plot and we have 2 lines of fit. So we want to be able to determine which one is better. So y equals x plus 4, does that one fit this scatter plot better, or does y equals x plus 4.2 fit it better? And so I'm going to do one table here. It's going to look like the examples that come before this, if you want to look at some more. We're going to start off with drawing a very, very long table here. And I'm going to start off with my first column here being my x. My x's that are in the table are 1, 2, 3, and 4. And my actual outputs, actual y, my actual outputs are 4, 7, 8, and 6. So you should see I pretty much copied this table so far. So now I want to get my predicted value. I want my predicted y from my first equation, y equals x plus 4. So the way we do this is, if I think that y equals x plus 4 fits the data really well, I am going to use these inputs into my line of fit. So I'm going to use x equals 1 and do 1 plus 4. X equals 2 and do 2 plus 4. And I'm going to get outputs that way. So the first one is 1 plus 4, which is 5. The second one, 2 plus 4, which is 6. 3 plus 4 is 7, and 4 plus 4 is 8. Next, I am going to look at my residual. So residual for the equation I just used. And this means, residual means I am taking the actual output minus my predicted output. I want to see how far away they are, because if I remember that these points aren't going to be on the line. If they were on the line, these would match, right? And they don't perfectly match. So sometimes they will match, some points will, but not all of them. So I'm going to do 4 minus 5 for the first one, which is -1. I'm going to do 7 minus 6, then 8 minus 7, and 6 minus 8. Okay, remember I'm doing actual minus predicted. Actual minus predicted. Next, we're going to do the other equation. So we're going to do the predicted y value for y equals x plus 4.2. And after that, we'll do the residual for that equation. for y equals x plus 4.2. So the predicted y value, remember that I am going to use these x values over here way on the left side and plug those into my line of fit equation, the pink one there. So I'm doing 1 plus 4.2 is 5.2, and then 2 plus 4.2 is, that is 6.2, and then 7.2, 8.2. When I subtract the actual, okay, look here in the second column, actual minus my predicted y value for that equation, I get negative 1.2, I get 0.8, 0.8, and what is this last one? Negative 2.2. So the next step is we're going to square each of the residuals. Okay, so from this column, I'm going to square. So squared residuals means I'm doing negative 1 squared. That's my first residual right in that column. And I'm going to add that with all the other ones squared. Okay, so these ones are pretty simple. Negative 1 squared is 1, plus 1 squared is 1, 1 squared is 1, and negative 2 squared is 4. So altogether, that is 7 is my squared sum of the squared residuals. Next is the pink one on the left side. We got some decimals here to deal with, so this one's a little bit trickier, but still pretty small numbers. We're hoping to get small numbers because you'll see here in a moment that's how we determine which one's better. So we have our squared residuals here are negative 1.2 squared. Whoops, that squared should actually be outside, sorry. Plus 0.8 squared, 0.8 squared, and negative 2.2 squared. And from there, it becomes, what is that, 1.44 and 0.64, 0.64, and 4.84. So when I add these all up, I'm going to get, give me a moment here, 7.56. And that's the sum of my squared residuals for the second line of fit. So if you look at the directions at the top, it says identify the lesser sum and the line with the better fit. So with that helps us conclude that y equals x plus 4, that's my first equation, is a better line of fit. Let's move down here a little bit, because it has a lesser or a smaller sum of squared residuals. Okay, so looking at residuals is going to help us determine if the scatter plot actually is close to our line of fit. Okay, this is how we test it. Okay, I'm going to skip all the way ahead to page 458, another your turn here, and we're going to look at number 10 has us looking at the latitude of various cities and their average temperature. So we want to be able to do a line of fit for this. I'm not going to worry about this, interpret the correlation coefficient. Don't worry about that. But we want to use the line of best fit to estimate the average temperature of another city. And it actually gives us the latitude of Trenton, New Jersey, right there in the middle of the table without an average temperature. So it gives us the latitude. So I'm going to show you how you can use Desmos to figure out the line of fit and our unknown temperature there. So I'm in Desmos. And to get to Desmos, you can see the website's right there, desmos.com/calculator. Once you get there, there's this plus sign near the top left of the website. Once I hit that plus sign, I'll be able to add a table. And this table has an X column and a Y column. So I'm just going to start typing in the values there. Let's see if I can move this. Whoops. There we go. I'm going to zoom this out just a little bit so I can type in here. Okay. Now I'm going to type in my latitudes in this column. 3.2. And I'm just hitting enter for each one that I type in. Makes this a little bit quicker. And I don't know, the 40.1 is this Trenton, New Jersey, so I'm going to skip that one. And then my Y values, I need to put those in. Okay, I need to zoom this out some more. Or let's move over our other page there. There we go. Okay, so putting in the Y values now, the average temperature. So I got 18 degrees Fahrenheit, 29, 34, 37, skipping New Jersey. Whoops. Okay. So from that, I'll be able to see, I should be able to see it on my graph somewhere. There we go. So there it is on my graph. Nice, it's those green points. Now this looks like it has a negative trend. So I can see that it's going to have it should have a pretty good line of fit. It's almost in a straight line, almost. It's really, really close. But what I'm going to do is I need to enter in a new equation right underneath the table. So if you remember, we have x1, y1 as our column titles for that table. So I'm going to type in y1. I'm actually going to type in y equals mx plus b, but it's going to be in a slightly different format. It's going to be y1. It's going to be this tilde sign that's down here at the bottom. If you can see on my keyboard, it's that right next to the comma. And then next is x1. Whoops, that's actually wrong. I'm supposed to type in m times x1 plus b. And this is going to give me my line of fit. What you see right below that is the slope right there and the y-intercept right there. That would go into the y equals mx plus b. So here's my line of fit. Very close to all the points. So with this feature, you don't have to do this by observation and kind of guess what you think the line of fit might be. This actually gives you a very, very accurate one. So next, I want to figure out what if x is 40.1, how would I figure out y? So one thing I could do is you would have to click on this purple line that I have here, or your line of fit, and if I hold down on the line with the cursor, I can actually see all the points going along it, and I can just kind of drag, and I want to go to 40.1. So 40, and it's very hard for me to keep this still. There we go. 40.1, 40.1, 40.294. That's one way to do it. Here's an easier way. Look at the left side of this website page, and you can actually type in x equals 40.1. This is going to give me a vertical line with all the points that have an x coordinate of 40.1. It gives me all of them. And from there, my black line that you see here, I can actually tap on where the purple line and the black line intersect. And there we go. I don't need to do any dragging and trying to keep my hand still. It tells me that right there. So I'm going to write it down on that page on the left side, and that is 40.294. That's my answer. Okay, and that's going to be it for this lesson. Do play around with Desmos if you get a chance to. You can also download it as an app on a smartphone. It's a very, very powerful tool. Let me know if you have any questions about how to use it. Definitely come in and see me. Okay, thanks for watching. Hope it was helpful, and have a great day.